So this is the third application of Gauss law to find the electric field due to two parallel uniformly charged sheets. And this is the diagram. This is case 1 when first sheet is positively charged and second sheet is negatively charged. There can be 4 cases. So this is first case when first is positively charged, you can see, and second is negatively charged. So our first requirement is to put the arrows of electric field. Okay, this is region A, this is region B, and this is region C. So now you see first sheet is positively charged, so electric field will be away from it. E1 is away, E1 is away, and E1 is away in all 3 regions. You can see these 3 arrows. It should be away from first sheet. Don't see second sheet. Now coming to second sheet is negative, so arrow of electric field should be towards it. Electric field is from positive to negative. So see this arrow, one arrow to be put in region C, it should be towards negative. This is also towards negative in region B, and this third one is also towards negative in region C. And the name on it, on these arrows, E2, 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 because we will look at 2 only. Second sheet, which is negatively charged, the arrow should be towards it. So now we are ready with it. Now we know electric field due to single sheet is given by sigma by 2 epsilon naught, which is second application of Gauss law. This is electric field due to single sheet. So let us see. Yeah, this is the formula that we have. Now in region A, see, let us apply this formula to write down electric field due to 1, sigma 1 by 2 epsilon naught. Electric field due to 2 will be sigma 2 by 2 epsilon naught. Now in region A, you have to go to the diagram. You have to go to the diagram and look at the diagram very carefully. In region A, this E1 is along negative x-axis and E2 is along positive x-axis. So E2 will be written positive and E will be written negative. That's all. E2 is written positive and this I have written with negative sign. Substitute this sigma 2 by 2 epsilon naught. This is sigma 1 by 2 epsilon naught. Take 1 by 2 epsilon naught common. So this is my expression which is ready for electric field in region A. Now special case when the charge densities, surface charge densities of both are equal. Sigma 1 is equal to sigma 2 is equal to sigma. So when you put here sigma and sigma, you will get 0. Special case. Now come to region B. In region B, again to write down the expression for electric field, you have to go to the diagram. Let us try to draw the diagram once again here. That way we will learn as well. So this is positive. When you are putting positive charge, it is away from positive, away from positive, away from positive, and just give it the name E1, E1, E1 because it was my first sheet. Now my second sheet is negatively charged, the field will be towards it, towards it, towards it in all the regions. So it is E2 and E2 and E2. This is my region A which I have solved, and this is my region B which is to be solved. This is region C. So now you can see this arrow is along positive x-axis and this arrow is along also positive x-axis. So I have written both positive. Now just substitute the value, take common, done. This is the expression. Now special case when both will be equal, so sigma plus sigma will make 2 sigma, and this will be cancelled. So this is a result which is very important because capacitor's derivation begins from here. Electric field between the plates of a capacitor is like this. It is directed from positive to negative. We begin the capacitance of a parallel plate capacitor with this expression. So it's important. Now in region C, again you have to go to the diagram. So we have drawn the diagram just now. We can see this is positive x-axis. E1 is along positive x-axis and E2 is along negative x-axis. So we'll write E1 positive and E2 negative. That's all. Substitute the values and take 1 by 2 epsilon naught common. So expression is ready. This is an expression. This is a result. Then we apply a special case when both the surface charge densities are equal. If both are equal, put them here, sigma and sigma, it will come 0. Okay? So this is how this topic will be done. But then there can be 4 cases. So you should be ready for all 4 cases. So let us see it once, all 4 cases. Only diagrams, derivation will be same. So this is the case in which both the plates are positive. So you can see first one is positive. So it will be away and away and away. So here you have to write E1, E1 and E1. I have already done it. This is also positive. So field has to be away and away and away. So this is along negative x-axis, this is along negative x-axis. It means E1 will be written negative and E2 will also be written negative in derivation. ठीक है? So it will be sigma 1 by 2 epsilon naught and second one will also be sigma 2 by 2 epsilon naught. So minus sigma 1 by 2 epsilon naught and minus sigma 2 by 2 epsilon naught. Again you can take common and etc. In region B you can see this is positive and this is negative. Okay, so you can do this way. Let us try one more diagram in which both are negative. Let us do this. This is negative, so field will be towards it, and towards it. This arrow is for first sheet. So right here E1, this is E1 and this is E1. Now this is also negative. So towards it and towards it, electric field is towards it and towards it. Region A, region B, region C. ठीक है? So now let us see expression. Derivation will depend upon your diagram, which case has come in exam. Now in region 1 you can see this is positive and this is positive, so you will write both positive, E1 plus E2. E net will be this, then you can proceed with the derivation. And here this is negative, this is positive, so it will be E2 minus E1. Then proceed with your derivation. So that's all.